children, so today we will be learning about matrices. Now the first thing, try to understand what you mean by matrices. Okay, definition given here. A rectangular arrangement of numbers in the form of horizontal and vertical lines is called a matrix. Okay, matrix means it's just the arrangement of numbers in vertical lines. Okay, horizontal and vertical lines. So example, you can see here the numbers 1 2 3 4, these are arranged in vertical horizontal lines and vertical lines. Okay, so when you arrange this, okay, in vertical horizontal and vertical lines, okay, so it makes a matrix. Now a matrix, here these horizontal lines are called rows. Okay, these rows, and these vertical columns are called vertical lines are called columns. So horizontal lines are rows and vertical lines are columns. So it has 2 rows and it has 2 columns. Okay, and these numbers are called elements of matrix. Okay, and these elements are written in brackets like this. And these brackets indicate that it is a matrix. And normally a matrix is denoted by a capital letter A, B, C, D, X, Y, Z, etc. Okay, so we use capital letters to represent a matrix. Okay, so remember, matrix is the arrangement of numbers in rows and columns. Okay, it can have any number of rows or any number of columns. Okay, so these numbers, which are called elements, are written in brackets. All right, so now next is order of a matrix. What do you mean by order of a matrix? Now if a matrix A has m rows, small letter m, rows and n columns, okay, it has m rows and n columns, then order of A is given by m cross n. It is not m into n, it is m cross n, and has mn elements. Here it is m into n elements. For example, so here this matrix A has 2 rows, so m equal to 2 here, and n columns, so columns also 2, so it has 2 rows and 2 columns. So then order of matrix A here will be 2 by 2. Okay, so and how many elements will be there? 2 into 2, that will be 4. So there will be 1 2 3 4 elements will be there. Okay, so order of a matrix indicates how many rows and columns a given matrix has. Okay, for example, to understand it better, let's take a few more examples. Now let's take the first example. So see here, in the first row you have elements 1 2 3, second row you have -1 0 1. Okay, so what is the order of matrix? First we count the number of rows. So how many rows are there? See, these are horizontal lines, 1 2, so it has 2 rows cross. Okay, how many columns it has? See the vertical lines, columns, how many? 1 2 3, so 3 columns, so it has 3 columns. So order of matrix is 2 by 3. Okay, it's not, you don't multiply 2 into 3 6. Okay, it is 2 by 3. It is read as 2 by 3. So this indicates that this matrix has 2 rows and it has 3 columns. Okay, so similarly the second example, you can say how many lines are there? Horizontal lines 1 2 3, so 3 rows are there, and how many columns are there? 1 2, so 2 columns. So order of matrix is 3 by 2. And how many elements are there? You can multiply the 3 into 2, that is 6. So 1 2 3 4 5 6, so there are 6 elements. Okay, now we see equal matrices. What we mean by equality of 2 two matrices. When two matrices will be equal. So you see here, equal matrices. Now two matrices A and B will be equal if, okay, now there are two conditions. Okay, so first condition is if A and B are of same order. Remember, for two matrices A and B to be equal, first they must be of same order. If orders are different, then they cannot be equal. Okay, so orders of the matrices must be same. That's the first condition. Second condition is that the corresponding elements must be equal. Okay, so two things: order must be same, and the next condition is that the corresponding elements must be same. Like example here. So this matrix has order 2 by 2, 2 rows, 2 columns. This also has 2 rows, 2 columns, so 2 by 2. So both are 2 by 2. So they have the same order. They can be equal. Now next, that's not enough. So corresponding elements must be equal. So you see, corresponding meaning first and first, second and second, this third and third, fourth and fourth. These elements, corresponding elements must be equal. Okay, so then only the two matrices will be equal. Now let's see types of matrices. Okay, types of matrices. Now the first one, number one, row matrix. Row matrix meaning any matrix which has only one row. Number of columns can be any, doesn't matter. It has only one row, then it is called row matrix. For example, this one, 1, 2, minus 1. You see, it has only one row, one horizontal line, but it has 3 columns. Okay, columns can be any, it doesn't matter. So what is required is that it has only one row. So it is row matrix. So if there is only one row, then row matrix. Now number 2 is column matrix. So suppose here 1, 0, minus 1. See, here there are 3 rows but only one column. Number of rows can be any, but if there is only one column, then it is called column matrix. Okay. Now next, square matrix. Square meaning, you know, in a square the adjacent sides are always equal. Okay, length is equal to breadth. So if number of rows and columns are equal, then it's called a square matrix. For example, here 1, 0, 2, 1. It has 2 rows and it has 2 columns. So square matrix is 2 by 2. 2 by 2. Similarly, you can write 1, 0, 1, okay, 2, 1, 0, minus 1, 0, 1. This is another matrix. Now there are 3 rows, 3 columns. So this is 3 by 3 matrix. So you see, if the number of rows and columns are equal in any matrix, then it is called square matrix. Right? Now next, 0 or null matrix. Now in a matrix, if all the elements are 0, then it is called a 0 matrix represented by, okay, 0. Alright, so 0 matrix. If all the elements of a matrix, it can be square matrix or it can be a rectangular matrix, okay, column, a row, or anything. So if all elements are 0, it's called 0 matrix, a null matrix. Then identity or unit matrix. This is important. Okay, so we represent this by I. I stands for identity matrix. Now, identity matrix must be a square matrix. Remember, only square matrix can be identity matrix, and the requirement is that if it's 2 by 2, then this is identity matrix. Remember, these elements are called elements of principal diagonal, from top left to bottom right. The elements along the diagonal called elements in the principal diagonal. If elements in the principal diagonal each is 1 and the remaining elements 0, then it's called identity matrix. This is I2 means identity matrix of order 2. Similarly, I3 means this identity matrix of order 3. So 1, see, elements in the principal diagonal must be 1. Then the remaining elements must be 0. Then it is called identity matrix. Okay, you will know the property of identity matrix later on as you progress in the chapter. Okay, so now based on the concept that you have learned today, so we'll try to solve few questions. Okay, so let's take question number 1. So you are given 3x plus y minus y, 2y minus x, and 3 is equal to 1, 2, minus 5 and 3. So these problems are based on equality of matrices. Now you can see two matrices are equal. Okay, because this is 2 by 2, this is also 2 by 2. Now you know equal matrices, if they are of same order, then and the corresponding elements are equal, then they are called equal matrices. So since they are equal matrices already given by equality sign, means they are equal. That means their corresponding elements must be equal. Remember this one. Okay, corresponding first and first, second and second, third and third, fourth and fourth. These elements must be equal. So using this property, we can write equations. So we get 3x plus y. This is the first element here, must be equal to first element here, equal to 1. Equation number 1. Now the second element of the first row here, minus y is equal to second element here, 2. Okay, so here there's only y, so you can write this as y equal to minus 2. Equation number 2. So this gives you the value of y. Then third one, 2y minus x must be equal to minus 5. This is the first element in the second row, first element in the second row. And 3 equal to 3, there's no variable, so no need to write that one. So here the question is to find the values of x and y. Okay, y value is already found. So from equation 1, we'll use the value of y in equation number 1. So you get 3x plus value y is minus 2, so minus 2 is equal to 1. So in equation 1, we substitute the value of y, which is equal to minus 2. So y equal to minus 2. So this will give you the value 3x equal to minus 2 plus minus minus, so goes to RHS becomes 1 plus 2. So this implies x equal to 1 plus 2, 3 by 3, so it is 1. So this gives you x equal to 1. So we found the values of x, which is 1, and y equal to minus 2. But we have one more equation. So if these are the values of x and y, they must satisfy this third equation. So let's check. So therefore 2. So you can write from 3. So from equation 3, substitute the values of x and y. So 2 into y is minus 2 minus value x is 1 is equal to minus 5. Okay, let's see two sides are equal or not. So this is minus 4 minus 1 equal to minus 5. This implies minus 5 equal to minus 5, which is true. So therefore now our values which are found are correct. So x equal to, we have 1 and y equal to minus 2. So these are the values of x and y. Okay, so to understand better, let's take another example. So there are 4 unknown quantities, 4 variables there, x, y, a and b. So we have to find the values of all 4. So let's take question number 2. So x minus 2, y, a plus 2b, and 3a minus b. This is the first matrix, which is equal to another matrix 3, 1, 5, 1. So you are already given that these two matrices are equal. So that means their corresponding elements must be equal as before. So we make the equations now. So therefore x minus 2 should be equal to, you know, this is 3. Okay, corresponding elements. Equation here, from here you can find the value of this x here, because there is no y. So x equal to 2 goes that side, so 3 plus 2 will become 5. Okay, so then y equal to 1. Y equal to 1 already found, y equal to 1. Okay, so therefore next, so x and y already found. Okay, so these are the answer. X equal to 5 and y equal to 1. Now the third one, a plus 2b is equal to 5. Here there are two variables, so we cannot find the value of a or b. So we take is the equation number 1. And 3a minus b equal to 1, equation number 2. Here also we have two variables, so we number it as equation number 2. Now we have got two equations in two variables, a and b. Now what we do, we'll solve simultaneously by using any method. So here, since plus 2 and minus 2 we have, we make coefficients of this b equal, and then we can cancel it. So for that, to make coefficient equal, we multiply equation 2 by 2. So that 2 into b will be 2b, so it will get cancelled. So first equation, we haven't multiplied by anything, so as it is. Second equation, 2 3 is 6a minus 2 into b is 2b equal to 2 1 is 2. Remember, when you multiply equation, you have to multiply each and every term here. 2 into 3, 2 into b, 2 into 1. So now, okay, since sign are already opposite, so we add it. Okay, we don't need to change the sign. So 2b to b get cancelled. 6a plus 1 will be 7a equal to 5 plus 2 will be 7. This implies a equal to 7 by 7. That is 1. Okay, a value is found. Now we take any equation and find the value of b. So take equation 1. So therefore, from 1. Now what we do? In equation 1, we'll put the value of known variable a and find the unknown variable b. So a we know is 1. So 1 plus twice b we don't know. So write as it is, equal to 5. So take 1 to the RHS first. So twice b is equal to 5 minus 1. This implies b is equal to 5 minus 1 is 4, and 2 will divide, go 2 times. So b is equal to 2. So a equal to 7 and b equal to 2. So you can write a equal to 7 here, a equal to 1 here, value, and b equal to 2. So we found the values of x, y, a and b, all four variables found. Now let's take the last example for today. Okay, similar questions. These all problems are based on equality of two matrices. So let's take question number 3. We have a plus b and 3 5 plus c ab is equal to 6 d minus 1 8. Here also two matrices are equal. So we use the property of equality of matrices, which means their corresponding elements are equal. So therefore, here a plus b is corresponding element is 6, so equal to 6. So two variables, equation number 1. So 3 equal to d, so you have d equal to 3. Okay, already found the value. Okay, next equation, 5 plus c equal to minus 1. So therefore 5 plus c equal to minus 1 implies c is equal to minus 1 minus 5 equal to minus 6. So d and c values found. D equal to minus 3, c equal to minus 6. Now we have ab is equal to 8. Okay, so there are two variables, a and b. So now it's in the product form. So what we do is take this as equation number 2. Okay, now from 1 you use this relation a plus b equal to 6. If you square it both sides, then you get a plus b whole square is equal to 6. Or you can do it the simple way. From here you find the value of b. Implies b is equal to 8 by a. So equation number 2. Now put the value b in equation number 1 and do it. B is here. So a plus b is your 8 by a is equal to 6. This is from 1. In equation 1 we have put the value of b. Equation 1 is a plus b equal to 6 and b equal to 8 by 4, so 8 by a, so a plus 8 by a equal to 6. Okay, now we find the value of a first. So this implies, since this a is in the denominator, so multiply throughout by a. So if you multiply by a, it becomes a square. If you multiply by a, then you get 8 by a into a equal to 6 into a. Here also we can write in product form first, a into a. You multiply each term by a. Okay, you can take LCM and do also. So this will be a square, a will get cancelled. So plus 8, so this will be equal to 6a. So bring to LHS. So it's a trinomial. So a square minus 6a plus 8 equal to 0. Okay, so it's trinomial form. So we break up the middle term. So 8, you factorize 4 to the 8, 4 plus 2 is 6. So break up the middle term. So you have learned it in quadratic equations. So a square minus 4 plus 2a plus 8 equal to 0. Okay, so if you open the bracket, you get a square minus 4a minus 2a plus 8 equal to 0. So there are 2 negative, 2 positive, so it's fine. So take common now from these two and these two. Here a is common. So a you take common, you get a minus 4. A is taken common, so a minus 4. So here minus 2 common. So if you take minus 2 common, you get a plus will change to minus. 2 will go 4 times, so 2 plus. So when you multiply, you should get it back. 2 into a, 2a, minus into minus plus, 2 to 4, 8. Now a minus 4 is common again. So a minus 4 is common. So get a minus 2 equal to 0. So apply zero product rule. Either first factor is 0 or second is 0. So either a minus 4 equal to 0 or a minus 2 is equal to 0. This will give you a is equal to 4 or a is equal to 2. So we got two values of a. Now for each value of a, we find the value of b. So from equation 2, okay, so when a is equal to 4, we take the first value, then b will be equal to 8 by 4, that is 2. So when a is equal to next value 2, b is equal to 8 by 2, that is 4. Okay, so the values are, so therefore a is equal to, we have a equal to, when you have a equal to 4 and b equal to 2, or a equal to 2 and b equal to 4. Okay, and we have c is equal to only one value minus 6 and d is equal to, we have 3. So these are the answer. Okay, a equal to 4, b equal to 2, or a equal to 2, b equal to 4, or c equal to minus 6 and d equal to 3.